Okay, Assalamualaikum and a very good evening to all of you. As for today, me and my group will be presenting and explaining regarding question number 1 for SCL optimization. So before we start our explanation, I'll be introducing myself. The others will introduce themselves too. So we start with me first. So my name is Muna Arini binti Musa Elias Musli and my matrix number is 207154. Next, I would like to ask Najha to introduce herself.
Okay, my name is Norain Najiha binti Muhammad Yunus. My matrix number is 207406. Then I will pass to Siti Husna.
Okay, my name is Siti Husna binti Khairul My matrix number is 207293. Then I will pass to Nakib.
Hi, my name is Muhammad Nakib bin Muhammad Hussein. My matric number is 207640. So next, Arif.
Hello everyone. My name is Ahmad Arifuddin bin Ahmad Masri. My matric number is 207619. Then Farhana, can you introduce yourself?
Okay, hi, my name is Nitnofana binti Nik Aizan and my matrix number is 207591. Next person, Razita.
Hi, my name is Razita Rabiah binti Ibrahim and my matrix number is 207464. Next, I will pass to Azira.
Hi, my name is Nur Syahidatu Azira binti Saad. My matric number is 207159.
Okay. Now that all of us have introduced ourselves, so we will start by explaining with Nakib first to explain briefly about the question. Nakib, please.
Okay. So our group have choose question 1 to be presented today. So the question for question 1 is, a company needs to design a cylindrical can that holds 475 cubic centimeters of fluid. What are the dimensions of the can that would require the least amount of material? So for in this question, they ask for cylindrical can. So for more flexible, we should draw the cylindrical can and noted the radius as R and height as H. So we should from the question, we can come out with one equation. With the question mentioned that 475 cubic centimeters. So that means the volume of the cylindrical can is 475. So the formula for volume for cylindrical can is V equals to pi r squared H. So we get the first equation is volume of cylinder, which is V equals to pi r squared H equals to 475 cubic centimeters. So next.
Next, the function to be optimized is the formula of surface area, which is area top or bottom plus area outside. So the equation is 2 pi r squared plus 2 pi r h. Okay, next.
Okay, so next, the function, we have to write the function in terms of one variable, only one. So from the equation, pi r square h equal to 475, we make it h as a subject. So we will get h equal to 475 divided by pi r square. Then we substitute the h value in the formula A equal to 2 pi r square plus 2 pi r h. Then we substitute the h value, we will get A in term of r, which is A equal to 2 pi r square plus 950 r to the power of -1. Next.
Okay, so for the next step is we need to minimize the AR. We need to take the derivative of the object of the AR and find the critical values. So we need to remember that when we need to find the critical values, we need to set the derivative equal to 0. So as we can see on the slide that derivative of AR equal to 4 pi r minus 950 r power of negative 2. Then we simplify it to 4 pi r minus 950 over r square. And then we set the derivative equal to 0. And finally, we got the r, which is 475 over 2 pi power of 1 over 3. So next.
So next for the first derivative test. So basically, in order to get this sentence, we have to use the first derivative test. So it's just you draw a table, which is you need to know the critical values, which is the R here. So by knowing the critical values, we can determine the interval. So by knowing the interval, you can choose any number based on the interval and determine by substitute in the derivative of A. So you can get whether it is negative or positive.
So when the critical value have been calculated by using first derivative test, which got the value that is 475 over 2 pi square root of 3. So we assume that this value is a minimum value because the derivative changes is from negative to positive. So next.
Okay. We just need to answer the question. Okay, so from previous we got that r equals to 475 over 2 pi to the power of 1 over 3. So we just convert it to decimal form. So we got 4.228. And also h, it is also already have derived from before. So 475 over pi r square. Just substitute our value into it, and we got 475 over pi times with 475 over 2 pi, and then 2 times 1 over 3. So it will become, the power will become 2 over 3, and also just convert it to decimal form. Then we will got 8.457.
Okay. Hence, by the end of the calculation, we gain the dimension that will minimize the material use, which is for the radius of the can, it will be 4.228 centimeters, while for the height of the can, it is 8.457 centimeters.
All right, now that each of us have properly explaining the question number 1, I guess that is all for tonight. So thank you for spending your time in watching our presentation. So that's all. Thank you, everyone.
Thank you.
Thank you.
Bye. Thank you.
Thank you.